So who here is an aeroplane, helicopter, balloon, glider pilot of some kind? As expected, there's a few of you. First of all, I would like to apologise to the Lambda Jam conference. I was going to give this talk in May and on a Monday, and on the Sunday I decided to go for a motorcycle ride, and I broke my leg, and I couldn't give the talk. So yesterday when I was getting out of bed, I thought, should I go for a ride? Nah. I went flying instead. Let's go through this, right? So I live in Brisbane. I live near this airport here. This is a Class D airport, very similar to Essendon Airport down here. This is the circuit pattern for that airport, and you can see it crosses the Ipswich motorway there. And this would be me riding home from work. I would see one of those, and I would do that. That's not really me. And so I did that. And my wife was like, that's expensive. And then I won the argument. Very compromising. And she agreed. So just to give you an overview of aviation, certainly in aeroplane class, there's 4 categories of license. I have the first one. I'm studying for the second one at the moment. And it's regulated by an organisation called CASA. You've probably heard of them. And there's also Air Services Australia, which you might not have heard of. They give you information, weather reports and so on. And, New South Wales, Queensland rail gauges aren't quite the same. So we have international organisations as well. So aviation is agreed upon internationally. If you're coming head on, both turn right, that kind of stuff. In Australia, the law is governed by the Civil Aviation Act, under which is the CASR, and there's also orders. So, the wings fell off that aeroplane, I order you to fix it. Stuff like this. There's also advisories. So I'm going to talk to you about pilot logbooks simply because it's the simplest thing, I think, to understand, right? So this is the law. You don't try and read this. It says keep a logbook. Pilots must keep a logbook. The people who put their hand up, they have a logbook. The law says so. And that's one that I started. But if you go and have a look at this particular regulation, you'll find out that the answer is yes, you can have an electronic logbook as long as you can produce it. Someone comes up to the airport and says, show me a printable copy. You have to be able to print it on the spot. That's the law. So, turns out that if you go onto the aviation internet forums, this is going to happen. What's the best one? Well, an Excel spreadsheet. Some people use Google spreadsheets, and some people use some proprietary thing, and some people love it, some people hate it. And some people cross the date line and suddenly it stops working. Don't break the other one. Right. Some people lose their logbook. Whoops. And so on. So my argument, just in terms of logbooks, is you need to use a Haskell data type. Right? There should just be a value of the type logbook. Right? Inhabit that type, you're done. And how do you query it? Well, you use lenses and zippers and all the things that we do for data types. So this is real code. What does this do? It uppercases the surname, right? Aviation loves uppercasing words. If you ever read a weather report, you'll learn that. And so here's, give me the list. So this expression here is, give me the list of all the aircraft in my logbook. All right, so this is simply an example of composing lenses. So for those of you not familiar with lenses, it allows you to navigate an immutable data structure. So this dot here is like digging down into the tree. And it's saying, give me all aircraft from all flights. Find the first flight in VVO in a particular aircraft. I had to do that once. Someone asked me to do it, so I wrote the code. I said, there's the first flight in VVO. And some people say, how many day hours have you had? Well, that's just, again, another query using lenses. It's not like, I don't know, Excel, or it's a function. So, and if I ever get ramp checked, if someone comes along and goes, print it out right now, I'll be like, no worries, man. I'll just call that function right there, which prints out my data structure HTML. All right, and then hopefully I'll have a printer in my pocket. But the key point is of this particular issue is you get really obtuse queries in aviation. Like it's stuck in the 60s, man. this is an example. Like this didn't really happen, but I've had things of this nature occur. Give me the most obtuse thing, and I need to be able to write that code right now. And so basically, I want, however difficult that query is, I need to be able to write the code, as opposed to like using a proprietary logbook. Let's say if they ask me that question, I'd have to go through with a pen and paper. Have you ever seen pilots going through things with pen and paper? That's what they're doing. They're querying things in a linear fashion. Not cool. I'm not cool with that. So that's just a sort of I enjoy applying functional programming in like these practical applications. That's like a simple thing that I can just pick off. I'm done. I have a value of the type logbook. If it doesn't compile, it's not correct. So, for example, in that paper one, you could fill out both day and night hours for the same flight. Although you can actually do day and night. You could do VFR and IFR, which you can't do at the same time. You could fill that out, but if you try that on my logbook, that will type error. This is good. Maybe we should put aviation law in types. I'm looking at some people in particular. So, as pertains to aeronautical charts, so I'll tell you a few little things about aeronautical charts. So 175 says it's all about publication of visual navigation charts, and as a pilot in command, I must carry them, and so on. So this here is a 500mm by 1000mm aeronautical chart. I must carry this. It's updated every 3 months. I must play Spot the Difference every 3 months. You know that game? And I never open the maps. If you open one of those maps in a Cessna cockpit, you will crash. You can't see. Right? So I have to carry them. I don't open them. I memorise them. That's what aviation training is all about, memorising aeronautical charts. And but really, I measure the risk, right? So I do this, and I look back out, and I do this. Not cool. So sure, they exist electronically. Yes, they do. But you must use the approved ones, or you're committing an offence. Okay, I'll use the approved ones. Well, here's the approved ones: Jefferson, ASOP, and Oz runways. So Jefferson, is not Australian. It doesn't cover Australia real well, so it's really up to these two. But, right, so, paper charts are the authoritative source. These are like, air services publish these charts, and that's the source. So let's fly across JPEG files, right? That's really what happens. That don't geo-rectify. They don't line up. That's okay. That's all right. That 1 mile that is actually there, that's all right. I can handle that. It's all right. However, I actually live at Bellbird Park right here. See, there's an army range, there's a RAF base, and there's a rifle range. No worries, don't fly over those. And here's the airspace. That's Amberley, there's my house, there's Greenbank, and RA3, so that's 2,000 feet. RA3 is the highest level of restricted airspace in Australia. What happens if you go through there? I asked this once of the RAF, and this is the answer. Well, this is one answer. Is a fighter jet will come up to you on the front of your aircraft, wag its wings, and you're meant to know what you don't go and look up the documentation while you're flying. You're meant to memorise this, and you're meant to follow it if it turns left, something like this. I don't know. I'll probably fall out the sky. So this is the actual air services publication for interception by a fighter jet. Okay, no worries. Just use uncertified charts. Right? But this is a particular aircraft incident. ZK means it's registered in New Zealand. It's a New Zealand aircraft. This aircraft is controlled flight into terrain. So the aircraft was in control. It hit terrain. Why did it hit terrain? Well, first of all, and for those pilots who will know that this is one of the most dangerous flight conditions that exist, which is VFR and IMC. So basically, you're flying visually, you cannot look outside anymore because you're inside a cloud. For example, this is VFR and IMC. And all VFR pilots are trained to exit IMC if they encounter it. This particular pilot did not. Sustain the IMC. I'm a good pilot, I'll be good, I'll be right, I'll be fine. Very dangerous. And it's a VFR-only aircraft and a VFR-only pilot. And basically, in the investigation, they went and looked at his avionics, the electronic charts that were on board, and they found this. And I have a question for you all. This aircraft is currently tracking just west and south. There's a point coming up. How high is that point? Now, the pilots in the room will look at this number here and realise that the aircraft is at 3,500 feet above sea level. 2? Did someone say 2? 3? 3 is correct. Some people will say 1, but 3 is the correct answer. And unfortunately, this pilot hit that peak. And I'm going to break my line in another way. So that's what happened, right? So there were 2 factors to this aircraft incident, which was VFR and IMC, which is obviously, you know, a very significant factor and the primary one. However, we programmers, I argue, have a responsibility to not screw that up, right? Just in the same way doctors have a responsibility to not cut you in the wrong spot and all this stuff, we programmers need to make sure, you know, certain areas of the industry don't make these screw-ups. Even though it was a multiple screw-up, it was multi-fact. Most aviation incidents are. And it was off anyway. The terrain data was busted anyway by 600 feet. So compounding factors control flight into terrain. So that's about charts. Let's talk about fixed wing. So fixed wing just means aeroplane, really. Aircraft weight and balance. So here's some basic aerodynamic principles. This is how an aircraft works. This is the aircraft that my boss is going to buy me. He doesn't know it yet. And so basically you have the centre of gravity and the centre of lift. So the pressure of lift pushes up, and the centre of gravity is forward of the centre of lift, and this stabiliser here creates stability of the flight. And the same applies to every aircraft, every fixed-wing aircraft. So when I go flying, I need to make sure, for example, that the centre of pressure and the centre of gravity are in the correct spot. Otherwise, it gets a bit wobbly. Sometimes falls out the sky. Not good. It's pretty critical. Same for the A380. They have to do the same thing. They don't calculate it the same, but they do have to do the same principal thing. So weight is making sure we can actually get off the end of the runway, and positioning the CG is such that it's controllable. So you don't want it to, you don't want to pitch up and then you can't pitch back down again. Things like that. So basically, here's how I have to do it. I have to take the weights. I have to say, hey, what's your weight? And you're going to tell me something in kilograms, aren't you? Some number in kilograms. And I'm going to say how much baggage you got. And you're going to go like, I don't know, 10 kilograms. How much fuel have we got? Well, we've got 45 Cessna pounds. And the aircraft itself, so each aircraft is different. We multiply each weight by a constant. Hopefully don't get it wrong. Double check it. I like to do it 24 hours before we depart, just to absolutely be sure I am confident I have the right answer, and I'll get a yes or no at the end. I plot this on a graph. If it falls within an envelope, we're good to go. Okay, this happens. We've changed your aircraft. And I'm like, oh no, it's a different weight, different CG. So what really happens? Well, Jessica says, can I sit in the front? Well, Jessica's only, 50 kilograms, and I don't know, someone else might, whoever was going to sit, there's 80 kilograms. This matters. So I can sit there and recalculate, I'm going to get it wrong. If I do that on the tarmac, I'll get it wrong. I'm under pressure. Or I can just go, Jesse, it's only 10 kilos. It'll be right. I'll be fine. Hopefully I really am. So I rate them in hassle. This is what I do. Jessica's a function argument. If Jessica wants to sit in the front seat, I just put her in the other argument position. So are aircraft. And there's a package called Diagrams, written in Haskell, which I highly recommend. Basically, it's like a DSL. You write your diagrams out, and out comes a PDF. Here we go. So this is an example. Actually, I think I put it there. That's the real PDF. So this envelope here, I have to fall within this envelope. I've put, I don't know how much fuel on board, but I landed at that red cross there. That green line is the fuel burn. So as the fuel burns, I stay within the envelope, down to blue, which is the end. Like I ran out of fuel at blue. So I'm in very different trouble at that point. So that's how to do weight and balance. I'll quickly show you the code. So here's the real code. So what we were flying in, I think VVO. VVO is 1,684.3 pounds. That's real pounds. That's not Cessna pounds. So there's Cessna fuel pounds, but there's real pounds. What is it? Statute? Or something, I can't remember. Anyway, its CG is 40.6 inches. That's real inches, not Cessna inches. So Tony and Joshua are sitting in the front seat. Jessica's back there by herself. I put 50 US gallons of avgas, which weighs whatever that does, I don't know. 30 kilograms of baggage. There's 2 baggage areas, so 30 in one and 10 in the other. And that PDF is the result of that calculation. Then I just call that function, and out comes that PDF. So when Jessica says move to the front seat, I simply rewrite the program. Produce a new PDF. We're still within the envelope. We're taking off, or we're not. So that's weight and balance, right? So when you fly on the big aircraft, that's not they don't ask you your weight on the way in, right? That's not what happens. You're given a number. You're that number. The margins are fine. But in my aircraft, it's not the case. So I'll talk to you about ADS-B. So ADS-B, this is an area that I would like to do work, but I have not yet done enough to be satisfied. So the other two, I'm fine. Jessica wants to sit in the front, I'm good. That's fine. ADS-B, I want to spend a fair bit of work because I think it relates to things like the loss of MH370. That's a big deal. Air traffic and collision avoidance. 2 aeroplanes don't run into each other. How does that happen? Well, they're good communicators on the radio. That's how. Seriously. Or as in the one that was on approach to the taxiway, wherever that was, I can't remember. It was on the news. You know the one. You know the one? Where was it? Yeah, that's it. Cheers. And, the other guys on the radio are like, oh, man, he's on the taxiway. He got told to go around. So aviation incidents are usually multifactored, right? So in this case, someone on the ground spotted it, said, cold tower, he got the lights mixed up, he was about to kill 800 people, but it was averted. So ADS-B, what is it? So basically all aircraft are transmitting a signal, or certainly all IFR, all the ones that you would fly in for passenger or commercial use, are transmitting an ADS-B radio signal. What's on that signal? Well, there's the identifier for the airframe. Each airframe has an identifier, the call sign, its position, its latitude, longitude, how good is the accuracy of that position report, its altitude. So altitude can be a function of barometric pressure, so based on the air density at its position. The GPS altitude, which is sometimes not quite accurate, its rate of climb and descent, fast over the ground, or where over the ground, and so on. Is it declaring an emergency? So it has a history in modes. Mode S is the most recent one on 1090 megahertz, and it can be received without transmitting. And IFR means it's flying instrument, so non-visual. And in Australia, all IFR must be mode S by today. I don't know if that's the case. They keep delaying that. Should have checked. So we can receive these signals with a $20 piece of hardware. And I'll show you what that looks like. So first of all, I find this a little bit amusing. You might too. Is can we just create an aircraft like right here in this bit of airspace and transmit? Well, yes, we can. And what's going to happen if the aircraft is coming towards that aircraft? It's going to be told to divert by its traffic collision avoidance system. There's an aircraft in front of you. It's been spoofed. Divert. It can happen, and it has been demonstrated. So this is a bit of hardware. It's 2 software digital radios, just to improve the signal as to aerials there. And that's the copper ground plane there. It's got a Haskell sticker on it. Must work. And it's got a gyrometer on board. And a magnetometer, so it can know its heading and so on, a barometer. And today's challenge for me was to place this device such that I can receive ADS-B from Melbourne air traffic, and if anyone finds it, we really will be evacuated. So I had to make it so that I could do this, and it's up the top of the stairs there at the moment, being well guarded. And I don't know how well I've done on the first point of receiving Melbourne air traffic, but, well, we can go and have a look, actually. There we go. We've got some. So basically, I'll show you what's happening. So actually, I'll show you what's happening right here, right? So this is a Haskell record data type, and basically, these are the fields. So for those of you who are not familiar with Haskell, it's basically, this is like a class or a data type, and here are all its fields. Is it on the ground, yes or no? What's a good one? Is the position even valid? So aircraft have to have a certain kind of integrity check. It's latitude, longitude, altitude. The difference between the GPS reported altitude and the barometric altitude. Its speed and track. Is the speed even valid? How old is it? And so on. So basically, I can pick up this air traffic with a gyrometer using ADS-B, using about $200 worth of software, hardware and software. So the reason I did this is because I wish to undermine the existing systems. They are awful. And you, the paying customers of aviation, pay the price. All right, so there are manufacturers like Garmin and Honeywell. They make these awful proprietary avionics, and they give them to CASA, and they go, certify this, and CASA goes, yeah, okay, give us $20 million. And they go, oh yeah, okay, there you go. And then someone does software testing and ticks off some boxes and goes, certified. And I'm really not cool with that. I'm working on that. The other thing is that particular device can report its own situation, so its own latitude, longitude, how many satellites it's got. It can report its pressure altitude, so that's the barometer giving you that. And importantly, its pitch and roll and heading, and so on. So basically, with $200 worth of hardware, I can tell anyone where I am, where I'm going, which way I'm facing, am I rolling, yawing, what am I doing, and I can tell what other air traffic is doing. And one of my goals was to also throw it in the back of an aeroplane, go flying, SSH home, and send all this data home, just as an experiment. And I did that. So as I was flying along, I was SSH'd home, reporting my position. So people could even tell whether or not I was in a roll, cheaply. So let's have a look at the code. Oh, pardon? Yes, go for it.
Yeah, why would you transmit it when you can save it to a disk and take it home later?
I did that too. So I saved it to local, to a local storage, and when I made contact with a mobile phone tower, I transmitted it. Now that's not practical for a flight at 40,000 feet. I had another argument, which is like a whole rant, but it's about creating a mesh network between aircraft. Right? So my argument is, if there existed a mesh network of ADS-B transmission and reception, would we have lost MH370? And I think the answer might be no. Right? So there's a whole technical debate to be had there. But, yeah. Which we can have outside if you like, it's fine. So, oh yeah, it's JSON, because everything on the internet's JSON. Right, so, I mean, really, I was just going to show you this. That's the code. This is the code. Where's the code? There. So basically, read these things off the device and print them out nicely. And, I mean, usually if there was traffic overhead right now, you'd see this scrolling as it's reporting the traffic. But unfortunately, it's not. It's picked up some while I've been talking, or whenever that is, 12 o'clock. So you can see that the flight, that's the flight identifier there, AN319. The power is the strength of the signal. I haven't got a GPS plugged in, so that's not working either. And that flight is at 7,000 feet. Oh.
Yeah, that's funny.
Yeah, I don't know what happened there. I think speed is valid might not be correct. So that happens as well. So that's all I wanted to talk about. The whole reason, or the whole motivating factor for me is I have some programming knowledge. Where can I apply it? I looked at aviation and I said, wow, it's really easy to do good things. I've done things like I've caught my flight instructor downloading 1,200 documents off the internet with a mouse. Oh, there we go. Thanks. Often it doesn't report the flight number straight away. So that looks like a VFR flight at 1,200. Yeah, so I don't know, that's all I want to talk about. I find it an interesting application of functional programming because it's so easy to pick the low-hanging fruit. I can do a lot of cool things, so thanks.
All right, any other questions for Tony before we break for lunch?
Yeah.
Given that there's so much still hanging through, and there's so much money involved,
Yep.
where's your money?
Where's my money to pay for it, or why haven't I been paid?
Why haven't you paid?
So that's a really good question. So why haven't I gone and installed my bit of hardware in your flight home? And the answer is it's not certified for use, so it's illegal for me to do that. So wouldn't it be nice if I could walk up to CASA, right, and go, you know what, I don't have 20 million bucks to pay you to certify my hardware, but I do have a proof that it's correct. Like a mathematical proof that it's correct. And there's a bit of law that goes, if it's proven, then you get a free pass. Now, wouldn't that be nice? Now, that's just dreaming, right?
The laws of math are only commendable here.
Yeah, that's exactly right. So, yeah, unfortunately, laws of maths are not quite up to Australian law standards of commendability. But you know, that's my aspiration. I know it's unrealistic, but I will continue working towards it anyway. And money might fall in my pocket. And I know someone else is actually in Canberra. Yeah.
Cool. Did I understand correctly that receiving that signal and processing it, but without transmitting anything, could get you in trouble?
No. So the earlier version of ADSB required you to transmit before you received, like as a technical limitation, and transmitting is costly. So if you were to go and buy one of these transmitters, you know, you would spend tens of thousands of dollars just to do the transmission in order to receive. So that's in the mode C and mode B, but mode S we can just receive.
Yeah.
The thing that's illegal is like spoofing an aeroplane in the air.
Yeah, that's what I thought.
Yeah, absolutely, that is. Yes. Aviation Security Act, unlawful interference, that would be.
So you were saying that you were using this as I forget what you there, but like, you know, as a motivated example for functional programming. It sounds like a lot of what you're covering though is actually a motivating example for strong static typing rather than functional programming, which doesn't actually require strong static typing. You consider the lists and the like, which have all the functional aspects as well.
Yep. So I believe P equals FP, right?
Yeah.
So functional programming is just programming.
Yeah, okay.
Now, as for types and so on, we could have the types debate.
Yeah.
But I'm going to call it quits at the aviation barrier. It's like, you need to have types. I need it to be correct.
Yeah.
Right, I need to really know we're going to get off the end of the runway and so on. So it is true that I'm motivating only programming, but I believe P equals FP anyway.
Yeah.
So in terms of types, like I didn't have very strong, I didn't really prove anything, right? So latitude and longitude are doubles. Like game over. Yeah.
But it's not like you're saying you're making sure you didn't have the daytime hours, nighttime hours because of the...
Oh yeah, that's in the logbook. Yeah.
It's stuff like that sounds more like a typing issue rather than necessarily a functional issue.
I believe they're one and the same.
What about
really.
lenses?
What about them? I mean, I was motivating lenses. Yeah. So being able to navigate through the immutable data structure, right? Maybe I've lost what you're asking.
No, I'm just saying how much of that motivation, how much of what the benefits you got was because of the typing system rather than...
Oh, significant, yeah. So I have no doubt in my mind we could all go to Essendon Airport right now and find someone doing a manual task because they don't have types. There's no question in my mind. There'll be someone going, oh, someone filled out the maintenance release with a conflicting value. What shall we do? Let's make a phone call and just use types. happens over and over.
It's not just types, but pure declarative semantics too.
Yes. So yeah, you have to have both.
Yeah.
I accepted about 10 years ago that functional programming is one. So it just looks like I'm assuming that. But it has. So I've kind of moved on from that. Yeah. Yeah.
All right. Thank you.
All right. Thanks.